Today's lesson is about surface area and volume of spheres. Now, spheres are pretty simple. It's kind of like a 3D circle. Some people just call it a kind of a ball. It's kind of what it looks like. If you have a sphere, sometimes you'll draw it with a circle. You can draw a dotted line in the back and a solid in the front. And that's kind of how they'll visualize a sphere most times. So that's what it'll look like on a 2D piece of paper. Whenever you have your center, it's kind of like on your circle. There's our center of our sphere. And our radius is very similar to a circle. It goes over to the edge of the shape. That would be our radius on that shape. We also can have a chord of a sphere, and we've talked about chords. A chord is any segment that goes from one side of the circle to the other. But on the sphere, it's kind of similar. It starts on one side of the circle and goes to the other. Sometimes it can go through the center. Sometimes it doesn't have to. It just depends on what you're given in the problem. So once again, it could come from one point on the sphere to another. It could go through the center. If it goes through the center, it's called a diameter. So a lot of those things you've seen before. So I just mentioned diameter. It's going to go through the center. And then there's a word called great circle. And really, I'm not going to focus too much on this term. I've actually never seen it on an exam or anything, or ACT, but that's that other circle that I've kind of drawn in there. The next term we have is hemisphere. A lot of times when they're going to draw that one, it looks very simple. It's just half of a sphere. So hemisphere will be drawn like this. Half a sphere. I drew that part a little kind of high, but it's half of a sphere. Surface area of a sphere is a formula you got to be able to write out. And this one is definitely in your book. It is 4 pi r squared. We're going to practice a couple problems with surface area now. So on this first one, it says, find the surface area of the sphere. Once again, here's the formula, 4 pi r squared. So all we need to do is get the radius from that circle, and that's pretty obvious. It's 7. So we plug in a 7, and then we can plug this equation directly into our calculator. We don't need this step. So 4 times pi times 7 squared to get our final rounded answer. All right, we got 615.17, just 0.7. And our units are going to be centimeters. And surface area has what kind of units? Squared on area and surface area. This next one's a little bit more challenging. It says the surface area is given, and that number's over here to the side. It also says find the diameter. So you got to be careful. We're not finding radius, we're finding the diameter of the sphere. So we always start off with our formula, and I'll write out to the side. Surface area equals 4 pi r squared, and then we can substitute what we know. We know the surface area, and they gave it to us. I'm going to plug that in for the big S. 110.25 pi equals that part of the formula, 4 pi r squared. Once again, we are going to solve for r, but in the end we're going to use that to find our diameter. So a couple steps. What should I do first to get the r alone? Good job. We're going to divide by 4 pi inside parentheses. We want to cancel out that 4 in the pi. 8.77 equals r squared. And once again, to get rid of a squaring term, we square root it. So square root each side, and you're going to get about 2.96. That's our radius. We don't want our radius, we want our diameter. So what do you do to get our diameter? Multiply by 2. So it's going to be, 5.92. And our units are feet. Do I put feet, feet squared, feet cubed? Just feet, because this is just a linear dimension. Just a one-line dimension is measured in feet. Now we're doing something different. Now we're doing the volume of a sphere. this formula is definitely different than the surface area formula. It's going to be 4/3. Try that one more time. 4/3 pi r cubed. That's the formula for the volume of a sphere. And we're going to use that for example 3. It's pretty straightforward. Volume equals 4/3 pi r cubed. This is just an extra little piece. It doesn't matter. So 4/3 times pi. Our radius is 3. And then cube that 3. That'll give us our volume. Type that in real quick. I'll give you a second. I heard 113.09 millimeters cubed. Good job on the units. Volume is always cubed. Now example 4 is where it gets a little bit challenging. It says find the volume of the composite solid. Remember, composites are when you're going to be adding or subtracting shapes. Since we're dealing with volumes, we're going to be adding or subtracting volumes. In this shape over here, they have a cylinder, and they cut out what shape? A hemisphere. So it's a cylinder minus a hemisphere. And sometimes it's good to write that out in words. Total will equal the cylinder minus the hemisphere. So that means we got to find the area, the volume of the cylinder and the volume of a hemisphere. The first little formula is going to be pi r h. That's for a cylinder. So we're going to do that one first. The volume of the cylinder, so I should say V of the cylinder, is going to equal pi r squared. Well, do we know our radius? Yeah, it's 3. Pi 3 squared times our height, which is 5. Type that in real quick to get the volume of the cylinder. I'll give you a second. Alright, so I heard 141.37. Now we also need to find the volume of that hemisphere. So a smart thing to do is take the formula of a regular sphere and then take half of it. So for that volume of the sphere, the hemisphere, we're going to take that 4/3 pi r squared, pi r cubed, and then take half of it. So half of 4/3 pi r cubed. So that's what we need to be able to type in. And once again, we already know our radius, so all we got to do is plug that in properly. So pi 3 cubed. And we'll get that hemisphere volume. So we get 56.54. Now we've already talked about what do we do to get our total. We just subtract these two values. We subtract the 141 from the 56. So that's pretty easy to get our total. We do total equals that 141.37 minus 56.54. And what do we get for that total? 84.83. And what are our units on this problem? Inches cubed. Good. All right, here are our last 3 questions. These are your checkpoints. Go ahead and work on these 3 questions. All right, here we go in these checkpoints. I've already written the formulas out to the side. If I say surface area, I wrote that formula. It says volume, I wrote that formula. So this first one talks about the diameter, and it's given. However, in our formula, we don't want diameter. We generally want our radius. So how do I take this number as a diameter and turn it into a radius? Divide it by 2. So whenever you write that and dividing by 2, it's like saying half of that fraction. And so that's really written as 1 times 1 is 1, and 2 times radical pi is 2 radical pi. That's your new radius. That's the term you need to plug in to your formula. So surface area equals 4 times pi times 1 over 2 radical pi squared. So this one's kind of tricky for some people to type in, so be really careful. You could also simplify this by hand. Um, Simplifying it by hand, that's like saying 1 over 2 radical pi times 1 over 2 radical pi. Once again, 1 times 1 is 1. 2 times 2 is 4. Radical pi times radical pi is just pi. You could have just replaced this piece right here with 4 pi times 1 over 4 pi. Well, this is going to simplify easily. I don't even need a calculator on this one. This is like saying 4 pi over 1. And if you can multiply straight across, 4 pi times 1 is 4 pi. And 1 times 4 pi is still 4 pi. And 4 pi over itself is just 1. The only thing we need to do is put our final answer down. So we got to have our units. So surface area equals 1 meter squared. There's our final answer. On number 2, it says the surface area is 169 pi, so I'm going to plug that in. 169 pi. And then I'm going to bring down the other parts. Once again, we're solving for r. To get r alone, what do we get rid of? 4 pi. We divide by 4 pi on each side. Inside parentheses, if you want to get it right. So the pi's are going to cancel. If we do 169 divided by 4, what do we get? 42.25 equals r squared. How do you get rid of squaring a term? Square root it, so it's going to be 6.5, and the units on this are inches. There's our final answer. Number 3 says the radius of a sphere is 2.4. Find the volume. So that's pretty straightforward. Volume equals 4/3 pi 2.4 cubed. When you type that in, what do we get? 24.13? 57.91. And that's going to be units, which are, sorry, centimeters cubed.